Hello, everybody. My name is Chase Cagle, and I'm here with my teammates Mason Corpolongo, Nathan Wetzel, and Ryan Zigonina, and we are the Iowa State University Capstone team for King's Material.
To give a little background of King's Material, they're a wet cast concrete production facility located in Hiawatha, Iowa. Their products focus on aesthetic landscaping bricks such as pavers, slabs, and landscaping walls. They're also a huge push production facility with limitless demand in spring/summer. The objective statements for King's Material: we have to increase production throughput to 264 molds a day. By doing this with implementing standard work shifts and minimizing efficiencies such as machine breakdowns, and also creating and implementing standard work for pouring and stripping processes using the time study data, and also implementing an and-on light system to signify the need for empty molds for pouring and unloading molds off the conveyor line.
Moving on into the current state analysis methodology, our team was able to obtain the previous 9 months of production data from a production data log, and we were able to break that down into 5 different categories, including fully operational days, and then days that saw a deficit, such as due to maintenance, scheduling, personnel, and days that were claimed acceptable due to safety inspections and weather. The team was also able to conduct a work sampling just to be able to create a survey of the entire facility. So this recorded subjects such as machines, equipment, forklifts and rotators, and personnel, and it recorded the processes of stripping, pouring, handling, and wrapping, all over the course of approximately 14 hours.
For the time studies of the CSA, we took 3 different types of time studies: general fork truck time studies in which fork trucks were stripping and palletizing, and then time studies of the pour operators at their station. The chart on the left is the time study results of the small mold stripping process, which was the most common stripping process, and the table just adjacent to it is the table that helped us calculate standard time for completing this entire process in one whole shift. And the 2 work sampling charts of non-value added activities showing all the breakdowns of those, as well as all operator activities given in the current day. And as mentioned earlier by Ryan, we had the 5 categorical days that we wanted to compare the last 9 months of data. And with those 9 months, we broke them down into these categories, which show the percent of the 9 months that those days occupied, as well as their associated average production in the top left corner. And then the top right is the box and whisker plot to break down the percentiles of how much production was given in a day. And from this, we can see that the maintenance and fully operational days are the most common types of days, so we broke those down into the 2 histograms below to show the mold production even more specifically.
Moving on to the future state design methodology, in order to create a production schedule that hits the production target, it's important to stick to the standard time of 2.5 minutes when stripping the small molds with the demolder. And to mitigate delays and bottlenecks from the pouring machine, a color key was created for the manually operated and-on light stack for better visualization, communication, and production across the facility.
From all this, the production schedules for King's Material could be created. This schedule averages about 415 molds per fully operational day, utilizing the same 10 employees spread out throughout an 18-hour work period. It is important to note that in order to hit these goals, it is imperative that the King's Material management holds their employees accountable for meeting the standard time stated earlier. And as you could tell, the previous schedule said it was for summer production, whereas this one is for winter. Winter production takes place in the month of October to March, whereas summer production takes place in months April through September. The reason for this is some molds do not cure fast enough in the cold winter months to be able to be double poured. Therefore, this schedule only averages 385 molds per fully operational day. Now looking at the return on investment, for an additional rotator being bought, making King's Material owning 3 now, at an initial cost of $30,000, roughly 10 days of the year, resulting in about 14% of all maintenance days, would be transformed from maintenance at 222 molds per day to fully operational at about 400, the average of summer and winter months, yielding around $29,000 per day in revenue saved, which per year is about $292,000 in additional revenue. And lastly, the return on investment for the scheduling shows a reduced amount of maintenance days per year at now 29%, as well as scratching out all scheduling issues and turning all of them into fully operational days, yielding the 415 molds in the summer and 385 molds in the winter, resulting in a 19% increase in yearly revenue, as well as a 31% increase in mold throughput, with an asterisk because that is looking at fully operational days only.
Thank you.